The shortest path, my friends, is not always the shortest path. That's so deep, I'm getting to bends just coming up from it. We know that the STP path costs are determined by the port speed. It could not hurt you to be familiar with the following values. And for 10 gig, it's 2, 1 gig Ethernet, 4, fast Ethernet, 19, 16 meg, which you can run into a token, I guess, is 62, 10 meg, 100. We'll probably see some of those in our labs, and a 4 meg is 250. There are other speeds, and they've changed over time. As of February 2015, this is the latest list, and you may say, well, why in the world have they changed? Well, at one point, the formula gave us a cost of 1 for a 1 gig port. Well, that was fine, except then 10 gig came and we couldn't give that a cost of, 0.1. It doesn't work that way. So these are the latest speeds. You may want to check them on Cisco's website if you're watching this a couple of years down the road, but they don't change all that often. And again, these are the latest speeds. Now you want to keep these costs and speeds in mind when you just eyeball a map. And I just say when I eyeball, it's like give it a cursory glance and say, okay, here's what's going on. You can't always jump to the conclusion, or shouldn't jump to the conclusion at all, that the physically shortest path is always the logically shortest path. Now here is the actual same diagram that we just had in the previous video, one of them. Switch 1's connected to 2, 2's connected to 3, 3's connected to 1. And you could be asked or look at this and say, okay, which one of switch 3's 2 ports is going to be the root? And you just look at it and you say, oh, fast Ethernet 1, because that's the, physically closest. It goes straight from 3 straight to 1. Well, that would be fine, but it would also be wrong. Because the switch 3 to switch 1 path, the overall root path cost there is going to be 100, because you have a single 10 meg link. But the switch 3 to switch 2 to switch 1 root path cost is actually 38, because you have 2 fast Ethernet links on there. It's so easy to be looking at 100 meg all over a drawing or a map or a sketch or whatever, and then all of a sudden you got one Ethernet link that's 10 meg and your eye puts that extra 0 there. Not trying to scare you. Cisco's not going to try to trick you on anything like this. Just be sure you take an extra second to look at the speeds, and the same goes for your networking work as well. Now let's talk about changing some of these results we saw in the last video. Changing a port's path cost. Now, I've already got show spanning VLAN, I believe, up here. Straighten that out a little bit. Yep, there's switch 2. And 2 trunks are still there. Everything's the same from the last video. But let's just say that we want fast 12 to be the root. Well, one thing we could do here is change the port's path cost. And doing so is going to illustrate some other concepts for us as well. So let's go ahead and do that just for fun. We're in a lab. What could it hurt? Famous last words, right? Let's look at our options here for spanning tree. And the one we're interested in this time is cost. Change in interfaces, spanning tree, port path cost. By the way, I use the term path cost. Cisco documentation does too. If you want to call it port path cost, that's perfectly fine. So we're going to change that cost from a value of 1 to about 20 zillion, so I think we ought to just go with 9, because we're going to go with a lower cost. So let's see what happens when we do that thing. Well, we did get an immediate message, but we're going back to that message. I'm not skipping that, but I want to run this command every few seconds. Because one thing you'll notice is that port 11 went immediately to blocking. That was an immediate change. The cost took effect immediately. I didn't need to reboot or anything like that. So now we've got 12, and it's doing something called LIS, which you know what that is. That's listening mode. And then it's gone into the learning stage, or learning status, and it's taken over as the root. So it looks like everything's fine and dandy, but let's go back and double check. I want to show you one of these messages. You'll notice the line protocol here on interface VLAN 1 changed state to down. And we know that VLAN 1 is our default VLAN there, our default only VLAN interface. And it's our management interface, so that went down, and that doesn't sound like something we would want to have go down. So that was not good, but you'll notice at the end of the process, line protocol on VLAN 1 changed state to up. So we're good there. Let me run show spanning VLAN one more time, and you can see now that indeed that port is in forwarding mode. It is the root port, and its cost change to 9 was immediate. Now again, something I want to show you here is the status of those two ports. As soon as we change that cost to 9, first off, our interface VLAN 1 went down, but also Fast Ethernet 11 went to blocking mode immediately. So the change in the role was actually immediate. Fast 11 went straight to being the alternate port. Fast 12 went straight to being the root. But the kickover, if you will, from blocking to forwarding, the transition is not immediate. Fast 12 went into what we call listening mode, or the listening stage, the STP stage. Then, a few seconds later, ran that command again. Their status blocking, and now it's LRN, which is for learning. And then finally, it went to forwarding, which is exactly what we want. So just a couple of notes there for you. That's how you change the port cost. The change is immediate, but the kickover, the transition, if you will, to forwarding is not going to be immediate. Now, what we've got coming up next, got a couple labs for you. You might want to go ahead and jot this drawing down. I'll go ahead and go into this a bit here now, and then we'll do some labs. Because the load balancing on a per VLAN basis, the thing is, using the cost command the way we just did, it's an all or nothing deal. The port cost for every VLAN is going to be changed to whatever value we enter. So if I had 50 VLANs on there, the change I just made would be for all 50. But what if we want to change the cost for some VLANs while leaving it alone for others? And why would I do that to begin with? Well, between this video and the next one, I'm going to create 4 non-default VLANs, of course. I'm going to create 10, 20, 30, and 40. We'll see what the defaults are with what I have now. We'll actually then take that cost command off and do some per VLAN load balancing. We'll check that out on the very next video. See you there.